I'm sorry?
I'm done in 1 second.
I'm good. We're good.
Ready in 1 second.
So, Maria, do you want to see where I am when I'm in the right place?
No, you shouldn't move the camera, Spencer. You want to present from there? You want to tell where to see? They should, because it's movable, they should adjust the camera to the people. They have somebody watching the meet and they should adjust it. I hope they do it. So that's that looks promising.
Okay. That's us. That's us. That's just that. So I was like over here at the last. No, they didn't say that.
So actually this should be connected to the deck. I'm not sure why it's not showing up yet, but the side should show up. They will manage it at some point, I guess. Do you want to start or should I?
Let me send a quick, or is it, okay, something just happened.
Yeah, so there's
Here we go. Okay. Okay, yeah, I'll read it. So greetings to everyone. Welcome to TSV area at IETF 96. I am Spencer Dawkins. This is the lovely Mira. We have blue sheets circulating. Who's our scribe?
Medford, take notes. Thank you.
Yeah, thank you, Matt. Do we have anybody watching the Jabber Room?
You?
Oh, well, okay, and Lars will do that. Excellent. So thank you. Like I say, thank you all for being here. Yes.
I'm going to use the Etherpad, so if anybody else wants to help take
yes,
notes, that's
yes.
where to do it.
That will be great. Thank you. Excellent. So, let's see. Hi, yes, we call your attention to the note well. Please note well. If you have not seen this before, read it. If you have seen it before or have not seen it before, please act like you've read it before you start talking or sending email in this meeting. I'm going to walk through our share slides a bit. Let's see, where are we? Cool. Okay, cool. Okay. Yeah, we just wanted to remind people that we now have a transport area review team, and we want to thank people for serving on that. And the triage team that identifies documents that need special attention for transport reviewers, Allison, Wes, and Martin. Please be thinking about transport area director nominees. NOMCOM will be reviewing my position this year's cycle. The 2016 position description, nomination and form and feedback forms are at the link that's on the slides. Please nominate good people to be Miria's co-AD. Remember, this is Miria's current co-AD. This is me getting ready to do an AD review. And that is a steak knife. Please seriously consider serving if you're nominated, and please provide good feedback on willing nominees when NOMCOM asks. Let's see, where are we? Talk about the working groups that we have. We have 3 of them that are in rechartering discussions in Alto, in MPTCP, and in AQM. Yeah, and we are actually also looking for chairs to serve in several of these working groups. Please talk to the area directors if that's something that you'd be able to serve the community by doing. We have a lot of documents since 1990, IETF 95, and we just wanted to put those up. What's in the approved announcement to be sent category, what's in the RC editor queue category, and what RCs that have been published. So Mary and I decided we needed to start like noticing that, and we were actually pretty happy, I think, with how much we're putting out in one IETF cycle. So thank you all in the area for the work that you do. We have some BOF announcements. We have 3 BOFs this time. We have low latency, low loss, scalable throughput on Tuesday. Lars and Phil are the chairs. The BOF proponents are Bob and Con. And this is exploiting AQM mechanisms and scalable congestion control to provide low latency transport. Please go to the BOF if this is for you. We have the quick BOF on Wednesday with Lars and Brian Trammell as chairs, and Ted Hardy, Jana, and Christian as BOF proponents. And this is going to be standardizing Quick's core transport protocol and the mapping of the transport protocol facilities of TLS, and how to describe how to map the semantics of applications onto the transport. If this is you, please go to the BOF. And we have one plus path layer UDP substrate on Thursday. Aaron and Natasha will be chairing that one. This is from Ted, Miria, and Brian. And this is enabling the deployment of new encrypted transport protocols while providing a transport independent method to signal flow semantics under transport and application control. If this is you, please go to the plus BOF. Where are we? Oh, excellent. So, yeah, ready for our first talk?
Let's go back.
Oh, yes.
Agenda slide, because we have time to bash the agenda, and basically we already have something we want to add here, but David is on the mic.
David Black wanted to do quick clarification on what's going on with the AQM working group, since the post agenda is a little bit confused. AQM is going to be shepherded, I guess the best word, by the TSVWG chairs.
Herded.
Cat herding. We're good at this. We think. The AQM slot is actually Friday, even though the posted IETF agenda shows it as both TSVWG sessions. We're going to put the AQM discussion Friday morning.
In the TSV working group, yeah.
Yes, if you're interested in AQM, come to TSV Friday morning.
Cool. Thank you.
Yeah, we have two, I hope, or I believe, very interesting talks today. And afterwards, we have 3 shorter talks, which are all a little bit aligned around deployment experience. And we hope we have at the end another 15 to 20 minutes where we just have a discussion about deployment experience. So everybody's invited to contribute there. Before we start this official agenda, I would like Brian to go to the mic or come in front and talk about the Stack Evo program, because that's very related to a lot of work we do in transport and the IAB. So it's a good idea to give a quick update, and I appreciate that.
So hi, I'm Brian Trammell. I'm the IEB lead for the IEB Stack Evolution program. Who here has no idea what that is? I am in the right room.
All the members.
So we noticed a problem a couple of years ago, and the fundamental problem is, next slide, that we have this stack. We've been complaining about sort of how the stack is getting narrower and thinner and wider and rounder and in more dimensions and fewer dimensions for a very long time. Back to plenary talks well before I started coming to the IETF. And there's this fundamental dichotomy that it's really hard to take the stack of things that we have and move them in a direction in any organized way. It's hard to evolve the stack, but each one of these layers changes independently, so the stack is evolving anyway. Right, so it's just kind of, we've been going off the same cliff for the last 20 years, and we look at this and it's like, is there any way that we can at least change the shape of the cliff? So the 2 ways that we do that is by identifying the ways that the IEB can help and identifying gaps in IETF work in the area. And if there's anything the IEB can do to help, we try to do that. And if there are gaps in the work in the area, then we try to, actually it turns out we spend a lot of time suggesting BOFs. So here's what we've done for the past 2 years. This is the time that I've been the lead for the program, and also sort of the time since we had a program reboot, sort of the reboot of the set of operating programs within the IEB. We've held 2.5 workshops. We've had 3 BOFs. Well, we've had 2.5 BOFs, plus we'll be on Thursday, as Spencer said. We had a bar BOF that led to a proposed research group. We had a workshop report that was an RFC published for one of the workshops that we had so far. We've published a document on filtering. We haven't actually done any recommendations for the statements of the IEB, ways that the IEB can sort of sit in and say something and do something to help. We did start having discussion about a proposed statement on traffic classification, and that actually became a BOF. So pretty much every time we get together, we're like, oh, we should go do some work, and what happens is a BOF, because it's like a lot of these things are not things that need to actually be done by the IEB. They need to be done within the IETF. They need to be done with the open IETF process, so this happens. So basically, if you look at, next slide, if you look at a lot of the great work that's been done, a lot of it in the transport area as this rocket, we're this piece of uninteresting infrastructure over here on the right. This one stayed up.
So far.
Even with covered in flames. So, how to participate? There is an open list. All of the IEB programs have open lists. The open list for Stack Evo is stackevo-discuss@ieb.org. This list has actually been relatively quiet recently because a lot of the current focus in this area is on things like Plus. So that's all happening on the SPUD list, because Plus is the follow-up from the SPUD BOF that we had in Dallas about 2 years ago. One note on IAB workshops. We also occasionally have workshops. There have been, again, 2.5 that came out of discussions in the Stack Evo program. And we generally announce these on the IETF at IETF.org list that there's going to be a workshop. If you'd like to attend, please send a position paper. So the reason that we do that is we'd like the workshops to be more focused discussion among people who have, something that they'd like to say and can put the effort into articulate that in a position paper in order to get the invitation to show up. If we're in a situation where we want to have a big room full of people all talking, we turn it into a BOF. So with that, any questions? If there are questions, please ask them on stackevo@ieb.org. Thank you very much.
Thank you, Brian.
So Michu is next. Yeah.
I didn't touch this. Okay, maybe the other way around. You need this as well? Just attach it to the USB. It should work.
You're there.
In the USB, and it should work.
Okay, I can use the console. Oh, it works. Okay. I'll do both. Thank you very much. And my name is
Yep.
I have to stick in front of this one. Okay. Stick. Yeah. Yeah. Okay. All right. So my name is Michio Honda from NetApp, and I'm talking about really cool stuff called StackMap. This is collaboration work with the Kenichi Yasukata, our former intern student, and Russ there, and another Doug Santry, and our colleagues. All right. So let's go start from the very quick overview of the work. So we focus on the message-oriented communication over TCP, which is pretty common for the HTTP or Memcached or CDNs. So, but the problem is, so if we use the standard Linux network stacks, so we can serve 1 kilobyte messages only at 3.5 gigabps, and using single CPU core, which is much lower than today's network capacity. So the existing solutions include improving the socket API like Megapipe, but they show really limited performance improvements. So more radical approach is using user space TCP/IP stack or other kernel bypass TCP/IP stack. But the problem is that today's TCP is really, really complex. Okay, so because they have a lot of extensions and they are further complicated to cope with middle boxes. Okay, so in the end, maintaining and updating today's TCP is really, really hard. Okay, so our motivation is I want to use TCP/IP in the kernel, which is excellent, but I want high performance, and the StackMap achieves that. So it's basically I'm going to explain the features later, but in quick comparison, the StackMap is as fast as user space TCP/IP. Right, so let's start from the background in more detail. So again, we focus on TCP, message-oriented communication over TCP. And so the characteristics is that we have a lot of concurrent TCP connection because the busy servers has to handle a lot of clients. Also, they extend a lot of small messages, say the tens of bytes or hundreds of bytes. And as a result, the packet rates are really, really high. For example, millions of packets per second. So let's go into the code and how such a server typically looks like. So such a server basically runs infinite event loop by fetching event using equal weight and processing each ready file descriptors or connections by reading request, generating some response, and sending back the response, like read and write. So it works like this. So, but the thing is, okay. So the problem is already in this code. Okay, so when we have a lot of concurrent TCP connections, then return file descriptors by equal weight is pretty high, pretty large, quite a lot. So like in this case, the N is quite large. So when we have a lot of concurrent connections, so when this code is running, so the last file descriptor, for example, has to wait all the previous file descriptors to be processed. Also, when this code is running, so new requests are also arriving in the network stack already. So those requests are queued in the kernel. So what we can expect from this is the more we have a concurrent number of TCP connections, which is the x-axis, the more file descriptors are returned by equal weight, which is the y-axis is basically n in the code. So what we can expect from here is the more we have a concurrent number of TCP connections, we have the higher average and tail latencies. Okay, so this is the average latency is the bottom one, and top one is the tail latency, so which grows to the hundreds of the microseconds, so which is really bad. So okay, so now we have a problem. So how we gonna solve this problem? So in short, in which part of network stack or application we could improve. Okay, so in short, the processing cost of TCP/IP is not that bad actually. So this is the latency breakdown of the single HTTP GET and HTTP OK transactions. So basically, the packet IO input takes the 500 nanosecond, and TCP/IP only takes the 700 nanosecond. So the TCP/IP is doing a lot of jobs. So they validate all the packet headers, all the protocol headers, and they look up TCP connections, and they validate internal state, etc. They do a lot of jobs. But so given that, 0.72 microsecond is not that bad. But on the other hand, that the packet IO is just bringing packet or just pushing out packet. It takes the 500 nanosecond. I think it's pretty high, and also the socket on read and write and VFS layer also consumes a lot of time. So that's a problem. Okay, but anyway, so the TCP/IP cost is not that bad. On the other hand, some round trip latency reported by client application is about the 19.5 microseconds. So by dividing into half, it's a 9.75 microseconds. So the difference between 3.75 in the whole server processing is the 6 microseconds, but that is rather the minimum because we tested using OS bypass ping pong, but it reported the 5.77 microseconds. So that is pretty close to that 6 microseconds. Anyways, so but the story is further complicated or even worse when we have many TCP connections. So remember that the previous equal-based event loop code. So every equal weight, calling equal weight is cheap when we have small number of TCP connections, but it's pretty expensive if we handle a lot of TCP connections like this. So in conclusion is, so the conventional systems introduce a lot of end-to-end latency, say hundreds of microseconds, right? So the way it's expensive is socket API and also packet IO. And on the other hand, TCP/IP protocol processing is relatively cheap. That's our conclusion. So we can use feature-rich, very good kernel TCP/IP, but we have to improve socket API and packet IO. That's it. So how we approach to design stack map or towards solution. So basically, we need some new opportunity because there's no free lunch. So we are happy with dedicating a NIC to a specific application because this is common assumptions today. So this is also similar, same assumption with OS bypass user space TCP/IPs in most of cases. So we have now dedicated application and dedicated NIC, and then but we want to use TCP/IP in the kernel. So again, they have a lot of features and stable. So the question is how to connect that. So to interconnect those components, we use an extend netmap API. So in the end, we use socket API only for control, like socket bind, listen, etc. But for data path, we use a netmap API and extend it. In the end, we can do system call batching and packet IO batching across multiple TCP connections. And we can do zero copy, and we can do random completion. We can do a lot of things. But also by moving a packet between netmap and the TCP/IP stack, we pre-allocate the escape paths, which is operating system packet representation structure. And we also use static DMA mapping, because dynamically mapping, remapping DMA between memory and DMA or NIC is pretty expensive. So then how the API looks like. Again, so we use data path, we use netmap for data path, so the API is pretty similar to netmap API. So at a high level, it is pretty simple. So the client and server, the application has the application thread has a ring buffer, which is multiplexes multiple TCP connections. So also for each buffer, application puts some data, also indicate to which file descriptor this data should go. Okay. Then the client advanced head pointer, then they put another data and file descriptor, and so on. Right. So when the client or when the application calls some system call, which is actually IO control, then the backend or netmap stack map, the process these packets against TCP/IP stack, like putting a TCP/IP header and sending out to the NIC. So on receive side is pretty similar. In this case, basically the application see a ring buffer that multiplexes multiple TCP connection. So the kernel, the stack map puts data on each packet buffer and indicate to which file descriptor, to which file descriptor each data or packet buffer belong to. So but the problem is that if the application has to process data in packet arrival order, like just traversing ring, it is very inconvenient because the data belong to the same TCP connection might be scattered within ring buffer. So we allow application to traverse ring by file descriptors, like equal-weight example we introduced before. So the application can see that file descriptor array. This is exactly the almost same one with what equal-weight returns. And we use another data structure, which is indexed by file descriptors, which is unique within an entire process. So basically, the application can process each file descriptor by traversing the pointers, and like it is a pink line. So the application process file descriptor 1, 2, 3, like this. So let's go to the experimental result for some performance. So the implementation is currently the Linux, and we have to change Linux and netmap, and we need a separate kernel module. It's going to be improved in the future. So setup is pretty conventional, the back-to-back connected machines, which is of course in bare metal. So this here is the basic performance. So this is the red line is the same one with I showed before. Basically, this is simple HTTP server serving the 1 kilobyte messages using the 1 to 100 TCP connections. So the stack map, so x-axis is number of TCP connections or concurrent requests, and y-axis is latency or throughput. Throughput is in the bottom. So basically, the stack map sees much lower average and tail latencies and much higher throughput compared to the standard Linux. That's pretty good. So we ported the Memcached to run on top of the stack map, and so again, we use Memcached traffic with 10% set and 90% get, and the message size is again 1 kilobyte in this case. So we have other message sizes result in the paper. And we also compare the result with the user space TCP/IP, which runs on top of TPDK, so which is the C star, which is quite popular in industry. So again, we see much lower latency and higher throughput compared to Linux, and it slightly even outperforms the user space TCP/IP or C star, at least for this single CPU core. But when we use the multiple CPU cores, say in this case 148, and stack map works pretty well until the 4 CPU cores, but after 8 CPU cores, the C star starts the outperforming stack map. So the stack map doesn't scale as good as C star, but we have a lot of room to improve actually. So here's discussion. So what makes stack map fast? So actually, in terms of individual techniques like zero copy or etc., so nothing is new actually. We bring a lot of techniques from OS bypass TCP/IPs, but we can use TCP/IP in the kernel. That is a big advantage. And there's some limitation like safely sharing packet buffers. It's not systems aspect, but the application actually can see packet in retransmission queue, for example, if it misuses, misbehaves. And so it might cause some inconsistent state if application modifies some packet headers in retransmission queue. So we're going to address that in future work. So there is a lot of related work, but I think I don't have a time, so I'm going to skip it. And here's the conclusion. So we focused on message-oriented communication over TCP, and so we also found that kernel TCP/IP is very fast, but socket API or packet IO, they are slow and have to be improved. So the finding is that we can bring most of the techniques used by OS bypass user space TCP/IPs in the kernel, so that is pretty good. And we got a lot of performance improvement, and I'm refactoring code now, and will be publicly available in this summer. Yeah, that's it. Thank you very much.
Thank you. We have a little time for questions. You can also clap if you want to.
Michael Tuxen. The NetMap stuff and that kind of things are supported on Linux and FreeBSD.
It's only so far we focus on Linux only.
Do you have any plans to make this available also on FreeBSD?
Okay, so it depends on how the FreeBSD code is organized. So I want to talk to you about, for example, like how the code around putting data in socket buffers, etc. So okay, let's talk later. So, okay. But I want to talk in front of code. So,
okay.
Yucheng Chen at Google. I wonder how come your performance test is so small scale, like 100 connections, 1 kilobyte. Can you run at? There are a lot of benchmark tool that allows you to run millions of connections with different sizes. Do you have any plan to do that?
Yeah, so in the paper, there's the experiment using the different packets, different message sizes, and it's from 64 byte to the 1.5 kilobyte. But in terms of the number of TCP connections, so we only tested from between 1 to 100. But I expect that it's much higher performance than Linux because we have much less queuing of the messages in equal weight layer or the packet IO layer, etc.
So you are saying if I have 1 million concurrent connection, I'll see an even better result?
Yeah.
How much better? Do you have any ballpark gut answer?
So basically the relationship between
Are you just extrapolating those lines and?
Yeah, so the more concurrent number of TCP connection increase, okay, the more packets or messages are queued in the kernel or in equal weight. Okay.
It would be great if you just make that 5 orders magnitude larger and show.
Sorry.
It would be great if you test 1 million connections.
Yeah, definitely.
Yeah.
We should. Yeah, I want to tell you that when testing.
Yeah, thank you. So if you have more questions, just talk to him later. I guess he's willing to give more details as well.
Thank you.
So our next presentation is given by Volker. You can come up. You wanted this is use this as well?
Thank you. Yeah, hello, good afternoon. My name is Volker Süppli from the German Regulatory Authority. I'm here today to speak on behalf of BEREC, which we come to. Yeah, so what is BEREC? BEREC is the body of European regulations for electronic communications. Well, it's simply the body from the European Union where all regulatory authorities meet, and where we exchange our views and work on good practice solution on how to bring forward the European regulation. So that's it. And the content of the talk today is about the guidelines we are working presently on. In the last year, the European Commission has launched a new regulation on net neutrality and internet access services, and this has brought into force. So it is in force since April the 30th this year. So now our task within BEREC is to prepare some guidelines where we give further hints on how to work with this new law, how we will act on the law to make it a little bit more precise. And we have prepared a draft guideline already, which is under public consultation, or it was until today, or 2 o'clock this afternoon. So just when we started our meeting, this was closed, and now we will receive tons of comments. Up to now, it is, I guess, nearly 400,000 comments, and we have 2 weeks to go through them.
And it was fully on purpose to give this presentation right after the deadline, right?
Yeah, of course. We have planned this far in advance a few years ago. Yeah, surely. So, what is the task of the guidelines? In those, from the regulations we are having, there are some main topics addressed in there. I will just go through them. The first is that we have some transparency requirements, which are the most easy ones we are having. They are simply stating that if some provider is offering an internet access service offer, he has to state clearly what is in what is in the offer, what data caps, what speeds he is having, what traffic management he is using, whether there are something strange things are going on or whatnot. So the user who is buying this service knows what he is buying, and so he can also be able to check whether the service is fine or not. For the time being, it's mostly about speeds, because if you're buying an internet access service, you always look at speed, delay values, maybe also packet loss. The next one is about traffic management. This is a rather new topic for us, because in the past we have done only monitoring about speed. Now it's about traffic management, and the general rule is for internet access services in Europe right now is that from the basic consideration, you should treat all IP packets equally. But so that this should be the base how it should work from a broad view. And in a second step, there's something that is called in the reasonable traffic management, and this regulation allows to have some to have within the internet access service offer to have some categories of traffic, as it is called. So the reasoning behind that is that, for example, voice should be a little bit faster than email. So.
Just a very quick clarification question, because you said it should be independent of the application. So that really means the one specific application, not a group of applications, basically.
Yeah, that's it. So the whole thing is, from the categories of traffic we are having here, it should be based on some. It should be application based. So. You cannot say that you have a single voice service. Skype should be faster than other things. You should have to have a common objective reason for doing so. You can do some category of traffic for something like video streaming, for example. So that means that all services that are running via the IIS must have the right to use this preferred transmission within the IIS. And in the third step, we have some exception rules, which are meant only as if you are having some trouble. We'll come to this on the next slide. Maybe it's better here. So from the categories of traffic, just as I have mentioned right now, is that we have some groups there. The basic idea is that there are some packets that have some, we are always calling it some objectively defined reason. So you have, you could not use those categories of traffic for some commercial things, for example, that you have some zero rating going on, and the zero rating should be faster, and so on. So you must have a real good technical reason for doing so. And our task is to monitor all this. And for the exceptions we are having, there are three points mentioned in the law. That's why the first reason is that you have some complaints with other laws. Well, the basic meaning is in some member states, for example, they have some laws that you should block some content, for example. And the provider has to deal with this law, but we have a general statement in our law, in the European law, that you should never block anything that's going on. So then you would have your local law, and you have the European law, and you cannot handle it anymore. That's why we have this reason A. And the reason B is, if there might be some denial of service attack going on, you may block, for example, you have your specific reasons. And the other one is, which is more or less meant for the mobile environment. If you have a mobile cell, for example, there are far more users if you planned it. If there's some football matches going on, many people are at one single spot. In those times, you may block some services, you may throttle some services, so that at least VoIP can go on, that people can make phone calls and so on. And then we have another kind of service. The whole rules, the whole European rules are for the internet access service, but of course some providers may offer other services also, and we are calling them specialized services. I guess the FCC in the United States are using the same term for it. And some examples that we have also already mentioned in our guidelines is VoLTE, linear broadcasting of television services, and remote health services that are going to come up in Europe. And those may be offered as a specialized service, so they can be offered aside of the internet access service. And for those services, you can do whatever you want. You can block traffic. You can have some faster lines for those specialized services. There we do not have a rule for it. So we are just telling to the providers, our rules we're having are only for the internet access service and not for any other services. Yeah.
Quick question, Volker. Al Morton, would emergency services fit in this list?
Yeah, they would fit there also. If you have a good reason for doing so, the general rule is the provider can do anything as a specialized service, but he must have some good reason for it, and he must show the reasons to us, to the national regulatory authorities, and then we can give a statement whether it's fine or not fine.
Last second, I'm wondering, why is VoLTE high quality voice calling on mobile networks part of that list, but not other high quality voice calling on mobile networks?
Oh, just when we were drafting our guidelines, we were looking for some examples. Some people brought up this, so we have written it down. We could have written there any voice service with high quality or any.
Okay. Right.
So there's no special meaning there behind it. We were just looking for some prominent point to show people what a specialized service could be. Yeah, and so the last two bullet points is that we have there are 2 points that have to be met there. So you must have a good reason for providing it as a specialized service and not offering this as a normal over the top service over the internet access service. And the other thing is, if you're running many specialized services, for example, over your infrastructure as a provider, you always have to take care that the internet access service remains stable. So you are not allowed to drop the internet access service to, let's say, 2 megabit or so. So this is a very important point for us. But otherwise, if you meet those 2 points, you can offer any service you like as a specialized service. There are no limitations about that. Yeah, the rules we are having now with the new law is that we, of course, we have to supervise this. So we are now working on some monitoring solutions. We have to do long-term monitoring, short-term monitoring. We have to find whether some strange things are going on. And of course, if we see that some strange things are going on, somebody is doing something that is prohibited, we have to intervene. Of course, there are high fines for this, and so on. So this doesn't, but I guess it's the normal task you're having as an authority. Yeah, and what's now for us and the new thing that we have to do, the challenges we will have to meet in the future, within the next years, because this law is rather new. We have to live with this now. We have to bring it into real force. We have to find real practical solutions for it. The first thing is that for all European member states, which is also some big topic, because right now, for example, if you talk about speed tests, all member states in Europe have their own speed tests. But if you, it's not new to you. Of course, what is speed? What protocol should I use to measure speed, and so on. So right now, all member states have their own separate solutions. There is some little common view coming up, but of course, for the future, the big task will be to come up with a specific set of parameters we should measure, what measurement methodologies we should use, what standards we should promote, and so on. And the next thing is, the first was more on speed issues, the more easy task. Now we have, with a new law, we have a very strict limitation in this law that no throttling should go on. So that a provider should not have some commercial deal, for example, with some video streaming service. So this video streaming service is a little bit faster than all the other video streaming services. This is prohibited in the law, but we do not know how to find this. How you can tell this throttling is really going on. This is some tweak that the operator is doing. Currently, we do not know. That will be the task for the future. But from the legal point of view, from the law, we must find a solution within the next year, let's say. And according to this, we will build up our own systems, do our monitoring. But the problem is that we must have real proof, because there are fines. If we are setting some fine, we must have real proof, of course. But yeah, that will be, I guess, a real challenge. And the other thing is with the specialized services. So there will be operators at the markets that are not only offering internet access service, but also these specialized services. Maybe if they're offering those in parallel, they will have internet access service and let's say 3 or 4 specialized services. And we have to do some long-time monitoring whether this internet access service, for example, is over the long time is becoming worse and worse. And if the provider is aiming at these things to make the internet access service a little bit worse, a little bit more unstable, so he can promote his specialized services. This is also prohibited by the law. But the main point there is how we can prove it, how we can find some solutions there. Yeah, please.
Hi, there's a question from the Jabber room from John Leslie. What will the regulators say about DDoS remediation?
DDoS. We have in our present guidelines. You mean the point he's aiming at is how if we have a service provider, how we can deal with it, or if he may act on it.
Those words are the only information I have about the question that he wants to ask you. Sorry.
Yeah, for some DDoS attacks or whatever is going on, we have our special. We have it was in the slides where we have the exceptional traffic management things under point B. There we have some exceptional thing going on, and if exceptional things are going on that are posing some threat to the operator system, then he may do whatever he thinks what is fit to solve the problem. That's the main issue. But for all those specific points, if you come now to specific points, we have just made some broad guidelines for the time being, and we for all those specific points, this will come up in the next half year or so. When we have a look at the providers, then we will learn, we will see what's going on, what will be the most feasible solution, and we will talk with BEREC on the best way to go forward. Yes, Al?
Thanks. Thanks for an interesting summary, Volker. I'm really glad you brought this here. Yeah, for the reason, the second part, really, the QoS part, there seems to be so much emphasis, almost exclusionary emphasis on measuring speed. And yet that's only one of the key determinants for overall internet service quality of service. So have you given thought to measurement of, for example, DNS response time? Because the DNS server is very often a key part of service, and that's provided to the customer very often either in cooperation with another ISP or by the ISP itself. They may want to do that to use their own proxies, for example, things of that nature. Also the number of interconnection points with the internet, and obviously if you have a problem at one of these points, the speed in getting your packets to that point is meaningless. Now the packets aren't going anywhere. They're not going out the peering point. So, having it, and really a lot of service providers, they live far away from where I live normally, but they have, smaller ISPs. They may have one peering point. It may not even be in their country. It may be in another continent. So there's a whole realm of problems that are captured under the broad view of QoS that need to be controlled. And also looking for just something simple like availability. What percentage of the time is this system usable? I think that's an important metric which has got to be part of the overall quality of service. So I'd really love to see the regulators help us de-emphasize this monotonic view of speed is everything, and then give us some time so we can figure out how to measure it.
Yeah, thanks. Yeah, from all the points you have mentioned here, it's a good summary of all things we have already talked about within BEREC. Of course, for many things we do not have a solution or some common. The problem is always to have a common solution, because each NIA for itself, we have all our own measurement systems. Yeah, we do not talk to other people about it. We just build it, we use it as we like, as we want to have it. But now, if we want to find a common European solution, of course, many players at the market, each NIA has a specific view. You have some, your local environment is always different. Each NIA has a different focus on specific things. Yeah, but for example, DNS response time, for example, this is a parameter that is very valid, and I guess this will be in, of course. We also talk about video streaming access times, and so on. Yeah, please.
Matt Ford. I actually read the guidelines on the flight over here. I have such fun.
The deadline is over, you know, right?
There's a long section in the guidelines that talks about zero rating and commercial arrangements, which you didn't really touch on in your presentation. And it doesn't really draw any hard conclusions, I would say. It's sort of a bit vague about how this should be treated, and leaves a lot of stuff up in the air. But it does explicitly say that BEREC considers that a comprehensive assessment of such commercial and technical conditions may be required. So I'm wondering, is that in BEREC's work plan to actually kind of review the use of zero rating in the European marketplace and come to some stronger conclusions about the extent to which it's distorting competition and etc.? Yeah,
the reason why the text is so vague in the guidelines is because we have a very vague law. In those guidelines we're having, the guidelines cannot go over the law. And that is a limitation we have in BEREC, unfortunately. We, of course, as a regulatory authority who is working on practical solutions, we want to have strict rules that we can easily manage and use for all market players we're having. But yeah, unfortunately, well, zero rating is a big issue. It's the big issue going on, but the law has a clear statement that zero rating is not prohibited. So we cannot do anything against zero rating. But of course, we can do anything against some zero rating of offers that will be present at the market, or that are already present at the market, if there is some discrimination going on. And we can only, there are no rules for it. So that's why we are still vague. But of course, we will, from the comments we receive, we will see what's going on. But I guess the main thing will come in the next year, or within a year, when we have, when each NIA has seen what's going on its single local market, where we found some solution, where maybe we have some fines, we have some things going on, maybe some providers will go to court. We will see what the European Court is telling us, whether our rules are fine or not fine, or whether they are against the law. We will see, we will learn. It's a learning experience we are doing now. Thank you.
Lars Eggert, so second L, thank you for trying to summarize something that's a very complicated topic, obviously. And I'm trying to summarize it more in my head, and maybe it can't be done, but I'm wondering, so my really short summary would be that operators can use capacity that is otherwise unused in order to provision these specialized services. Is that
that's
roughly?
True. Yeah.
So that's good, because that's sort of the hint of what I've been getting, but what's sort of maybe the overarching theme here. And then I'm immediately wondering, so what happens in situations where there is no excess capacity, right? Because then immediately that means that the specialized services will take away from the general internet services. And because I mean, I don't see the operators building out extra capacity that they can then use to offer these services. I see that they're going to constantly be pressured by the market to run at capacity or slightly below. And so in my mind, by definition, every little bit that's going towards specialized services is actually being taken away from the internet.
Yeah.
Right? And that's why I'm struggling with how it's possible to do anything here, really. And I'm hoping you have a good answer for me.
Yeah, we'll see what the provider is doing. We are doing not planning for the provider, so he has to think about it, whether he should start a specialized service or several specialized services. The only thing that of course, you are right. If you not build extra capacity, you will take it away from the internet access service, of course. But there we have again our transparency rules, where you have the minimum, maximum, normally available, and those advertised speeds. It's a very complex thing. It would take too long to mention it all. But if this was happen, if a provider is now, let's say he's offering 3 specialized services in parallel to the internet access service, then and he will take away some quality from the internet access, then he must then he must fail in some of those values, minimum, maximum, so on. So the solution for the provider could be, I'm not offering any more 100 megabit access lines. I'm okay because of specialized service. I need those infrastructure I have for the specialized services. So I will go on to 50 megabit internet access services. And this is from a legal point of view, totally fine. He may do so. But once you have your, once you want to, you have your internet access service at some stable level, and you want to keep the level, and then you want and then you want to offer extra some specialized service, then you have to extra build something. That's that's a reasoning in the law and also in the guidelines.
We should try to wrap up here for the next.
We might need beer for the rest of the discussion, but so I'm wondering, because so it's never stable in the internet, right? Capacity always gets added, and so the operator obviously has a choice what to do with any additional capacity, right? They could, without specialized services, that would all go to the internet. Yeah. And now some of it might not go to the internet. That otherwise
we need to go ahead and cut the line.
Yeah, of course, it's speculation.
Yeah, Roland Beske, IT. So yeah, you have the problem of trying to realize in itself contradictory EU rules. So just like Lars mentioned, this is one contradiction in the EU rules. But other than that, it's what I'm also missing, and that's also not said in the EU rules, is the openness for specialized services for other providers. Like, I mean, if some provider has its own voice over IP service, getting preferential treatment, the EU rules do not forbid that this is exclusively done for the whatever VoIP provider, but it's not open to other voice over IP providers, and that's actually missing.
Yeah, okay, yeah, but I guess we cannot change that because the law is like the law is. Yeah, yeah. It's a parliament, it's not me.
It's always parliament, right? Matt Mathis, I'm wondering if there's any, I didn't hear you say anything about any provisions for monitoring things like headroom or available reserve capacity or anything like that, because one of the things that's deceiving is it's easy to think about priority in QoS in terms of sort of steady state stationary statistics, but in fact the traffic varies so much. QoS really only applies during peak load and stuff like that, and other than that you almost always have enough capacity where nothing matters. But monitoring that there's actually enough capacity is a significant signal.
Yeah, we, for the time being, well, what we have done so far, we are on a very abstract high level. We are aware of those points, but from a practical point of view, we do not know what to do right now. That's why we are starting a new work stream within BEREC. Within 1 year, we will talk about those topics. Maybe some aspects I've mentioned here are unsolvable. I don't know. Then we have to change our way of dealing with those things. Yeah, but yeah, we are just starting right now. That's why we are also here, and we want to talk about those.
So there will be more discussion tomorrow in the IPPM session on measurements.
Right.
Okay.
Yeah. Maybe it's a further question after the meeting. address me. Thanks.
Thank you so much. So we will have 3 short presentations now, and then we take all the questions at the end of these 3 presentations and have a larger discussion about the topic.
So my name is Ian Sweat. I work for Google, and I'm going to talk a little bit about deployment of Quick at Google. And so I'm going to start out with some fun, weird things that we've seen. Some of them might not surprise you, and some of them might be a little more shocking. So first slide. So the first one is large-scale reordering. So I was really surprised to see this in traces, but we see packets reordered by more than 100 packets and more than an RTT. In the worst case, I saw a RTT and a quarter. I think it was like 140 packets. And I didn't have to look that hard for this. It was kind of surprising. So this plays havoc with loss detection, as you might imagine. At least standard loss detection. So it's surprisingly common. However, larger packets are almost never ahead of smaller packets. I mean, it does happen, but not at that scale. It's more on the area of like 3, 4, 5 packets at a time. So we're working on quantifying exactly how frequent this is. But in terms of if you look at flows that have a lot of spurious retransmits, this large-scale reordering is responsible for a fair amount of it. And I also don't know at the moment whether it's UDP specific or TCP specific. So that's kind of follow-up work to do, but definitely something of note. And to deal with that, we're working on time-based loss detection that does 2 things. One is allows reordering on a time level, so any one packet getting very far ahead of any other packet doesn't mean anything. So we're willing to allow one packet to arrive ahead. You know, if half your flow arrives at 200 milliseconds and half is at 50, then, well, we don't really have a great approach for that. You just have to adjust your reordering window. But that's the other approach, I guess, is that we're working on adaptive reordering. But doing things time-based instead of sequence number-based or packet number-based definitely helps in this regard. So, the other one is rapid NAT rebinding. So we don't see this very often. When we did early studies, we saw this almost never. But it turns out, especially when a network is overloaded, under some conditions, some users appear to see NAT rebinding on the order of less than 15 seconds. Because we do a keep alive every 15 seconds. If we have an active connection, we haven't heard anything on it for 15 seconds. It seems to be isolated to a small number of networks. When we tried to get some data on this, it was a tiny number of users on a tiny number of networks, but those people who were affected, it seemed to happen all the time. It wasn't any large ISPs you've ever heard of. The users who were complaining about this were all kind of on like small university networks, corporate networks, and other places with like probably like less actively managed networks, and it was not enterprise grade NATs or anything that seemed to be causing this, or CGNs. So our solution to this was connection ID based routing. So now at Google, we have routing based on connection ID. So if you send the same connection ID to the same IP, even if the client is on a different IP or a different port, we'll make sure it gets the right server, and we'll make sure that we try to continue the connection. So that's a benefit of Quick that allows this address migration, even if the NAT does switch your address mid-connection. So, next slide. So packet misrouting. We saw this only about 2 weeks ago, or at least we didn't have the monitoring for it up until then. We saw cases when the switch was actually duplicating and spraying packets across a rack. This happened to be a switch we didn't own. This causes really weird errors. Turns out it causes really weird problems for TCP and Quick, but it's a little bit easier to monitor in Quick because we spit out like random connection close errors, and TCP just sort of like shoves it and like throws it away and like you don't notice. So yeah, I mean, it's not that common in terms of portion of the internet, but like at any given point in time, we seem to have like 1 or 2 racks on Earth that like have this problem. So, you know, something is always broken. Like, you know, you just have to like monitor it and like, I don't know, like ask someone to fix it, and then they might. And then it'll break again the next week because they didn't really fix it. So yeah, I mean, you can monitor this on a server. This is a straightforward thing, but like this is a real thing the internet does, and we did see, and it does cause weird errors that you never see otherwise. So next slide. UDP rate limiting. So we've talked about this, and I put this towards the end because it's actually a lot less common, at least on a large scale, than it was even a year ago. So we're seeing about a third as much UDP rate limiting now, at least that we can notice, as a year ago. Now, Quick is mostly deployed on non-mobile networks at the moment. We do have a fair amount of mobile usage, but it's definitely lower than the desktop usage. And that's mainly because the YouTube app, which is a large portion of our egress, is not fully deployed. But even so, we just don't see a lot of UDP rate limiting, and there are all signs of it getting better. So we still have the ability to disable Quick for the worst affected users, but that list is getting pretty short. We do try to contact ISPs in some cases, but in a lot of cases, they don't even realize they're doing it and they don't know how. So it's typically a case of if we get a response, they're like, I don't think we're doing that. It's like, well, it looks like you're doing that, so we're stuck. At least for the short term. So, so sudden black holing of packets partway into a connection. So for a while we were seeing traces all in a particular service where about like 5 or 10 seconds into a connection, nothing, like absolutely nothing for the rest of the connection. This is about the worst thing you can do to a connection, right? Because you really get it up and going, you have like 10 requests outstanding, and then it's like, so this is very user visible. This is very hard to detect because everything looks like it's going swimmingly for the first 5 seconds, and it breaks like everything. So we had a lot of user complaints, and in this one case, we actually did contact them and get them to fix it relatively quickly. But it was one case. I mean, this was like, I put it up as a unicorn because this is like the only time we've ever seen this. But if you see this, this is terrible, and this is sufficiently hard to detect that I would argue that like really the network provider like needs to be contacted because it's really hard to deal with. So,
Aaron Falk, Akamai, how do you know it was the network?
It was happening for every user on that particular network and on no other network.
Narrows it down.
This included me. So anyway, there's no reason to name who it was, but yes, multiple Googlers were able to use this network and verify that this was a problem with traces. Okay, well, yeah, that was a different problem. So here are some upgraded metrics on how often Quick works. So I want to break this down because the percentage of people where Quick isn't used at all is actually only the 4.5% that it's blocked for the user and the 0.2% that it's blocked for the AS. So that's like 4.7-ish%, which I think jives up with recent metrics that have been circulating around. The Quick Works category is Quick is used for the request. Chrome is on, Chrome has it enabled, the service supports it, like everything is good, and Quick is actually used. UDP rate limited is the portion of traffic or portion of users who we are seeing enough rate limiting that we've decided that like we're going to turn Quick off because it's problematic. That's only 0.3%. As I said, that's about a third of last year. And then the other one is that, Chrome loses the race. So that's a case where UDP does get through, one can speak Quick, subsequent requests say for a given page load do use Quick, but that particular request doesn't because a packet was lost in the Quick handshake and it wasn't lost in the TCP handshake or something happened. I mean, some event caused Chrome to decide to use TCP first and then switch over. So that's kind of a breakdown of where we're at today. And that's the end of my slides, I think.
Only if you have a clarification question.
It's really just a clarification. I think
and nobody else needs to go onto the mic because we have the discussion at the end.
Yeah, it's Matt Ford. I think you said this before, but this is not for wireless networks. Is that right? Not for mobile networks.
So this does actually include some amount of wireless data, but is mostly not wireless data. I mean, even on a mobile device like Android, I think 3/4 of the Android usage is Wi-Fi. But yes, this is more desktop than Wi-Fi.
Not just responding to the question also, wireless or cellular? Cellular.
Yeah. Hello, my name is Christoph Pasch from Apple. And yeah, I have been asked to talk about the deployment of MPTCP. Next slide. So I actually wasn't really sure what to talk about because it kind of just works. So Apple Siri and Gigapath in Korea and several other startups, well, they deployed MPTCP. And at least from our perspective, from Apple's perspective, it seems to kind of just work on the network. Yes, there are middle boxes that are, for example, removing unknown TCP options. There are middle boxes that might be dropping SYN segments with unknown TCP options. But overall, it seems to be that 94% of the MPTCP connections are actually successfully using MPTCP. But maybe it is also just working because the deployment that are being deployed nowadays are mostly in a very kind of a controlled environment where those who have deployed it, they control the client and they control the server, and so they kind of know what they are doing and who they are talking to. So next slide. So if we would extend the deployment, there are kind of quite some questions to actually answer. So for example, how would an MPTCP API look like? Because the initial goal of MPTCP was to be basically a drop-in replacement for TCP. However, there are lots of unanswered questions like, when should we create a subflow over the cellular interface? When should we send traffic over the cellular interface? Like, nobody wants to watch Netflix and after watching the video realize that half of the cellular data has been consumed just because MPTCP decided to improve the video quality by a small percentage. So those are kind of questions that still need to be answered in a larger deployment. How would this kind of functionality be exposed to the application to decide where to send the traffic over which interface? And so there's some, and the MPTCP working group, there now came an IETF draft up that tries to at least start a discussion about this and how can this be handled. Next slide. Another thing is, if we would go further with the deployment at an even larger scale, for now the most deployments are mostly at medium to small scale deployments. How would this kind of deployment look like in an environment where we have a load balancer in front of a data center who's doing ECMP hashing over the flows and sends each flow to a different server in the data center? With MPTCP creating a TCP subflow for each interface, this kind of load balancer would send each TCP subflow to a different server, and so MPTCP would not work. So there are some work needed to handle this by maybe replacing the load balancer with a different device that is MPTCP aware, or maybe some other changes in the infrastructure. And there's quite some discussion going on as well in the working group about how to address this problem. Next slide. And finally, there are also some new emerging use cases coming up with proxies, where lots of startups mostly and network providers want to deploy MPTCP in such kind of an environment where we have the end user who is using TCP to a transparent proxy at the home, and then this transparent proxy is multiplexing traffic over different interfaces, for example, DSL and LTE, and then this MPTCP traffic gets then aggregated again in the other side in the internet by a proxy. And so there are some changes that are needed to the MPTCP protocol to make it actually work in such kind of an environment. And with this, it's the next one.
Thank you. So Dave, you can basically stay here or come back after Dave's talk so people can ask questions, if we have still time.
Okay, so the area director has asked me to come and give a short overview of a document that's part of the IAB right now, which is why I'm temporarily wearing my IAB hat. I know there's a couple of other IAB members out there in the audience. Some of this was discussed at the IEB retreat this last year, and it's been updated since then, and so we'll talk about that. Next slide. Okay, so there's multiple types of transitions between operational and various technical kinds and so forth. The ones that we're talking about here are protocol transitions. There might be some principles that are applicable outside of that, but the scope of the document is limited to protocol transitions, right? What's a transition? Anything that changes from one state to another state in terms of deployment. Next slide. Okay, so RFC 5218 was a IEB RFC on what makes for a successful protocol. What makes for a successful protocol actually had a number of observations that are relevant to any type of protocol transitions. Right? That was one of the various topics, and that this document is elaborating on those. And so it made sense to reiterate a couple of the points that were in 5218 that are relevant to any type of protocol transition. Right? And of course, TSV area is considering many types of protocol transition and has done so, all the way from ECHN, which is one of the case studies that appears in the document now, up to things like, QUIC and MPTCP and so on and so forth. Right? So 4 of those, and sorry I have to turn around to look here, from 5218, 4 of the things that are critical to facilitating protocol success. Remember, the context of this is these are criteria that facilitate as opposed to hinder success. Okay? And so incentive, right? Success comes easiest when the benefits come to those that bear the costs. So if I have to make a change in order to deploy stuff, then I get some benefit as a result of making that change. And to succeed, I should say it's easiest when each entity that has to make a change gets some benefit, as opposed to I make the change, you benefit. Incremental deployability. Transitions are easiest if the first entity that makes a change immediately gets some benefit. Okay? Doesn't mean that you have to have that, it just means that it gets easier as long as the first adopter gets some benefit, or perhaps the second adopter after the first adopter, the 2 of them get some benefit, a third adopter gets some benefit after that, and so on. As opposed to we only get some benefit once everybody does it. The third point is about total cost, and often people think about certain aspects of cost but don't think about all the collateral systems like billing and accounting and training and documentation and legal fees, whether that's related to patents or licensing or permissions from governments or whatever it is. Okay. And then finally, and these are roughly ranked in order of most facilitating success down to least facilitating success, and then I drew the line because there's some below this that are contributors that aren't as important or perhaps that aren't relevant to transitions. But the last one is to design for extensibility so that things can be fixed up later. All right, next slide. And so there's 2 graphs in there that just illustrate how deployments happen. And the first example, labeled A, this is a case where the first entity that makes some change immediately gets some benefit that outweighs the cost. So obviously there's immediate incentive on the left side. Now, this is common in some cases and rare in other cases. In many cases, you get something that looks more like the right side, which is there's a bunch of long-term benefit, but you don't get it until a sufficient number of things have happened. Okay? Whether those sufficient number of things are entities like peers, or whether the different subsystems like billing, accounting, training, and so on and so forth that are perhaps developed by different organizations or different parts of a large organization. Okay. Next slide. So that was a summary from 5218. The IAB also recently had an Internet Technology Adoption and Transition or something like that workshop that the RFC is cited here, and that made 2 other observations that might be relevant to people talking about transition strategies. The first one was a part of an anecdote that some people might be able to learn from, which we looked at to the extent that Bitcoin became successful. What was one of the driving factors that got it to the level of success that it has today? Well, it turned out that one of the key successes that was there, that was part of this paper that was presented at that workshop, was that the earlier you adopted, the more benefit you got. Okay. Now, in some sense, you might say the same was true about IPv4 address space. Yeah, exactly. The second observation was don't underestimate the ability for various policymaking organizations to help in transitions. Okay. And so whether that is things like address space, or whether it is in terms of evangelization, and so forth. All right, next slide. Now, often comes up, well, there's this transition versus coexistence thing, okay? And when solutions are designed that are actually backwards compatible, there's no real significant difference between these two terms. But when you have something that is not backwards compatible, say IPv4 and IPv6, then there can be a big difference between these two terms, right? Transition usually implies we're going to switch from one to the other, and coexistence usually means we simultaneously have support for both of them during some interim period, okay, before we remove the older one at the end, okay? And so, hopefully some somewhat obvious things are on the slide here and are in the document, but it was good to sort of capture them for people that might be designing a new document or a new protocol. All right. The longer the overlap period is, the more costs of sort of operationally maintaining both in parallel. The shorter that period is, then the more difficult it might be to change on a whim. So a transition is just a special case of a coexistence period of basically 0 or approximately 0, right? We try to cram all the transitions into the shortest period of time. And so part of the observation is that anytime talking about a transition, it's important to consider what is the ideal length of that overlap period. Is it 0? Is it 1 day? Is it years? And so on. And there's a bunch of different costs that play into different points on that space. And of course, there's no single right answer because it may vary by protocol or example. Okay. Next slide. So when having non-backwards compatible changes, or sort of new evolutions or new revolutions of protocols, often we see this need for doing translators or adapters that sit in the middle of the path, perhaps co-located with one end or the other, perhaps in the middle. And there's some considerations there that we call out in the document. Obviously, if it's in the middle and it needs access to it, then there are certain end-to-end principles that get to be more difficult, shall we say, that we had to deal with in things like the Behave working group that I was co-chair of. And translation, putting the translation at one of the two endpoints can cause some resource issues, for example, if it's a constrained node, right? And so another example of this transition when doing non-backwards compatibility things is to think about where is the appropriate point to do translation if there needs to be translation. Is it in the middle? Is it at the initiator? Is it at the server end, or whatever? And to have some consideration of that. Next slide. Okay, I think this is my last slide. And so we said many times when generating a protocol, it's good to come up with a transition plan or a transition strategy at least, right? Is it a flag day? Is there an overlap period? What's the recommended thing, or what do you foresee doing? Okay. And so we said, what actually makes for a good transition plan, right? Are there good ones that are out there? Well, part of this document, just like 5218, we tried to say, so we want a number of use cases, and we'll have some observations, and we'll try to back those up by use cases. And right now, there's only one use case that's already in the document, and that's ECHN. Other ones in a process of being written. We've got IPv6, CIDR, and maybe IDN or something like that might be added. Those are in progress, but some of the observations are already in here. And so these are the things that we think make for a good transition plan. An explanation of incentives for each entity that has to make some change. Okay. In other words, do they get is the benefit aligned with the cost at each particular entity? A description of the phases. So, for example, if it's not backwards compatibility, if it's not a backwards compatible transition, then there might be, for example, 4 phases. Pilot, coexistence, deprecation, and removal. That's an example that comes up in IPv6 and some other cases that has those 4. What is the proposed timeline? Is it a flag day? Is it a 20-year thing? Somewhere in between? What do you envision as being the length of the whole process? And then finally, an effective way to communicate it not just to the IETF audience, but to the audience of the entities that need to make some change, right? What's the communication mechanism, and how do we get that feedback? Okay. And anything that has at least all 4 of these is a good transition plan. And so that's what we have so far in the document. It is a document in progress, and any other additions or considerations gratefully accepted. So thank you.
Thanks a lot. I would like to, you can also clap this presentation. I would propose that we just grab 5 minutes of the break, and I would like to ask for Ian and for Christoph to come to the front again so they can answer questions as well for their presentations.
I will take off the IAB hat for any questions.
Go ahead.
Yep. Bob Briscoe for a question for Dave Thaler. Actually, on this very last slide, I think also a good transition plan says we may have got it wrong. In other words, when you're talking about a very large system, businesses come and find new opportunities you didn't expect, or businesses find things going wrong that you didn't expect, and so your plan's never likely to be right. So I think a plan with more contingencies in it is better, as that ought to be a 0.5. Yeah.
Okay.
Yeah. And the other thing I wanted to say about the policy organizations can help, they can also hinder. Take net neutrality and all that sort of area. And,
working with them can help.
Yeah. Yeah. Or put it another way.
Working without them can hinder. Yes.
Put it another way. VoIP over ARPANET worked in the early 1980s, right? And it took years to get VoIP to work. Nothing to do with the technology.
Hi, Brian Trammell, no hats. Thanks for this talk, Dave, actually, and thanks for the other 2 talks. And now that all 3 of you are standing next to each other, I'm going to ask Christoph and Ian, would thinking in terms of defining sort of the protocols and and thinking about how to actually deploy them, would a section that was the transition consideration section in an RFC have made your life easier, or would it have just been a thing that you're like, oh, look, more boilerplate, I'm going to completely ignore that? Given that the article of the transition plan document has an interesting look on his face, I'm thinking that might not be a good idea, but what do you think?
Yes, you guys first.
I think it's helpful to understand like what the challenges transitions may involve. I think would be I mean, let's not go into the esoteric items, but like right. I think it's fine to have a comment that says like, in order to transition to this technology, like obviously like we have a fallback to TCP. Right. I think not commenting on that would just be a grotesquely large omission. Right. Similarly, like, multipath and TFO and other things have to have a fallback mechanism. So I think anything that you think everyone needs to implement, I think definitely needs to be in there. Or anything that you would recommend any standard implementation to implement. And anything that's just kind of a growing pain, I think that's deployment experience. If it comes down to contacting someone or monitoring something better, that's useful, but I don't think that probably belongs in an RFC, but that's my gut. I don't know. Okay.
I think one thing also would be good is if the whole deployment story is kind of maybe sketched out from the client to the backend to the servers. What will the deployment of the new technology affect, especially from the server deployments point of view?
Thank you, Dave. Did you want to elaborate on your face?
Why don't you just take the mic off?
Yeah. I think things that are backwards compatible often don't need a transition plan. And so my only fear of making some section is that people start saying, oh, well, you forgot such and such.
I want to clarify that I wasn't suggesting that we do that. I was just wondering if they found it.
I know you weren't, but that's usually the path that people start pushing on us. So that's my only fear. I think there's value in having maybe a template or something if somebody wanted to optionally add one. I think we say something similar about privacy considerations. We say you don't have to have one if you cover security considerations, but here's some things you need to cover, whether you call it privacy considerations or something else. That's my thoughts.
Cool. Thank you.
Now we have 1 minute left.
This is Joe Hildebrand. I wanted to ask a similar but opposite question. What about forward compatibility? Thinking about how you're going to transition from this to a new thing, that can also elucidate, your design approach, version numbers, that kind of thing.
I think that was the extensibility bullet, but if you know any IAB members that would like to contribute text, Joe, that would be great.
Christian Wiedemer, Microsoft. Looking at Ian's presentation, I think there is something missing in Dev's presentation. And basically, a lot of the work done in Quick was sustained by a very interesting monitoring system. And being able to monitor constantly what was going on and how it was going on clearly has helped the engineering of the Quick solution. And, well, Dev, you might want to add that to your bullet list.
That's a good point.
Another author here.
Jana Iyengar, we're not breaking yet, are we?
We are already in the break.
Okay. There was.
So you have 20 seconds.
Thank you. There's one thing in the RFC, Dave, that when you talked about backward compatibility and so on, that reminded me of something that Jim Geddes told me about. It's a different kind of compatibility. It's neither forward nor backward. He calls it downward compatibility. And it probably comes from the particular instance that he has of X11 deployment. But I like it quite a bit. And it's something that we try to incorporate in Minion as well. When we try to do deployment, I think Quick incorporates it also. The idea is to make sure that when you're deploying something new, that it makes the world better, but also does not make the world worse for people who can't deploy it. But it provides an incentive for people to deploy it in the future. I think that's different than backward compatibility, but I think it's also worth noting.
So you're talking about things like TCP fairness, for example?
Not sure. So I'll give you a very concrete example here. When
we can take it offline, but I think I'd like to understand more what you're suggesting, since there might be something there.
Sure.
Thanks a lot for everybody being here. I think this was a very interesting discussion. We had just not enough time. So follow up in the hallway, contribute to the documents. Thanks a lot.
And the Stack Evo discuss list, I'll bet.
No, you have all the stickers. I have all the stickers. You like some of the stickers? Thank you.
And thank you so much for coming. That was great. And,